t. That means what, when t equal to 0, that means what, initial condition. When t is above the 0, whatever the graph we get, whatever the lines we plot, that is called what, state trajectory. Something like the state space is what, the area, the graph sheet, let us consider. So in that, state variables are the variables we are going to calculate, and state trajectory is how that particular variables are moving. That is called as what, state trajectory. Okay, this particular concept is called as what, state space analysis. Okay, so next we can understand that state model. So what is this particular state model is telling? So when you consider, let us consider single input, single output, continuous linear time invariant system. Okay, described the following nth order differential equation. So nth order differential equation. So this is the nth order differential equation what we have taken. So what is the equation we have taken? D to the power of n y of t divided by dd to the power of n. So plus a1 into d to the power of n minus 1 y of t. So that means what? From the uttermost, okay, so 1 degree will be reduced when it is, the equation is moving towards the right hand side. So whatever the LHS you are going to see the y of t, no. So where y of t is the output of the system, u of t is the input of the system. Okay, so here a1, a2, an are the coefficients. Okay, so that is what exactly the nth order differential equation for the linear time invariant system we are going to write it. So here where y of t is the output of the system, as I told you, here I have written here. So where y of t is the output of the system and u of t is the input of the system. So now let us define what is this particular y of t, y dash of t, y to the power of n minus 1 of t. See here what exactly we define is, if we take y of t is the output, okay, so that will be equal to x1 of t, we'll take it one variable. Okay, that is called what, state variable we can consider. So y dash of t indicates what? It is a differentiation of the one-time differentiation of the output. That is called what, y to the power of 1. That means what, y dash of t. So that particular word I will consider, that particular thing I will consider as x2 of t. That particular thing I will consider as what, x2 of t. Similarly, xn of t. So up to y to the power of n minus 1 of t will be equal to xn to the power of xn of t. So that is what we are going to define it. Okay. So else I can say that generally I can say that y to the power of k of t will be equal to d to the power of k of y of t divided by dt to the power of k. That means what? Y dash means what? Single differentiation. Y double dash means what? Two time differentiation. Y cube of t, that means what? 3 times differentiation. That is what exactly the meaning here. Okay, so it is just a representation mathematical. So I will share this particular content to you in the MS Teams and in our WhatsApp group, so you can go through it. Okay, so this is the equation B and this is the equation A. So normal y equation 1 is normal equation is equation A, and differentiation, that means what, we defined it. So that particular concept is called as what, equation number B. So now we are replacing that particular equation from the equations A and B. I can say that, okay, so x2 of t is equal to x1 cap. Okay, so x2, x3 of t will be equal to what, x2 cap. So what is the meaning of x1 and x2 and x3? You can see that, okay. So here I can say that what is x2 of t? Y dash of t. Okay. So y of t, if you differentiate, it will become what? x2 of t. Okay. So y of t means what? x1 of t. If you differentiate instead of y of t, if you differentiate x1, it will become what? x2 of t, correct? So I can say that x2 of t will be equal to x1 dash of t. Clear? So that is what here written. x2 of t will be equal to x1 dash of t, or else simply I will tell it x1 dash. Similarly, I can say that x2 dash will be equal to what? x3 of t. Xn to the power of dash will be equal to So we will find out the equation, what exactly will come in the picture, that we are going to write it here. That is minus of an x1 of t minus an minus 1 x2 of t. This is simply the equation will get reduced in this particular format. So I can say that y of t will be equal to what, x1 of t. I can say that x cap or x dash k of t will be equal to what, dxk of t divided by dt. This is the equation number D. So this particular equations number A, B, C, D we are written now. So all these equations are just a representations. So we are representing the equations in different format. That is what exactly we have written here. Okay. So is that clear to you? Shall we go to the next representation? Shall we go to the next representation?
Yes, sir.
Okay. So since this is a very simple concept, one time if you just go through it, you'll understand in a better way. See, and this particular concept nowhere required your integration, differentiation, your mathematical concepts and all. Just a small representations only it is requiring. So I can say that putting equation C, D in the matrix form we get. So here x cap, x1 cap of t and x2 cap of t we are taken in the x-axis. That will be equal to the what you call for that coefficients. Okay, so for example x1 of t, x1 dash of t will not be having any one particular what you call for that coefficient except a n minus 1. So similarly x2 of t will be having the coefficient like a n minus 2. That is why where this one will arise, no? So here this one will arise. So like that here x of t, x1 of t, x2 of t, so up to x, like that it is going to come. Okay, so here in the last we have taken a general format equation. So we represent this particular equations in the matrix form. Okay, so here for example if you multiply, okay, so x1 of t will be equal to, okay, so 0 into x1 of t is 0 plus 1 into x2 of t is x2 of t plus 0 into anything is 0. Okay, so finally what will you get? We will get like x1 cap of t will be equal to x2 of t. So if you verify this particular thing, x1 cap of t will be equal to x2 of t. So similarly, x2 of t will be equal to what? So x2 of t will be equal to what? 0 into x1 of t plus 0 into x2 of t plus 1 into x3 of t plus 0 into all. So it will be left out with 1 into x3 of t will be equal to what? x3 of t. So like that x2 cap of t, when you see it here, x3 of t is already there. The same thing we have kept in the matrix format. So in that particular case we complete this particular equation. So plus u of t. So u of t means what? Input. So here you can see that this equation. So xn cap. So for that it is applicable only because at last only it is 1 is there. Remaining all it is 0. So this particular model is called as what? State space matrix or state transition matrix. So here y of t, finally it is one representation. The output representation is what? Y of t will be equal to, y of t will be equal to 1 into 1 0 0 0 0 all zeros. We have only the 1 into x1 of t plus 0 into x2 of t plus 0 into xn of t. So here y equal to y of t equal to x1 of t. See here this equation y of t equal to x1 of t we are taken now. That we are going to represent. Y of t will be equal to what? X1 of t into 1 is x1 of t plus 0 into x2 of t plus 0 into all. So we have get this particular matrix form. Clear? So now that is the two things. Now we can define n cross 1 matrix and x of t. So which we shall call as a state vector. So here x1 of t, x2 of t up to xn of t we have written now. That is called as what? State vector. So consequently, that means what here? If f x of t is state vector, so differential state vector we are to take it. So differential state vector when we are talking about, it is x cap x dash of t if we take it. So we will get x1 dash of t, x2 dash of t, xn dash of t. Clear. So you can see this particular thing, x of t will be equal to x1 of t, x2 of t we have taken now. The same thing if you consider, okay, so if you consider differentiation of all those things, you will get like this. So after that, compactly means what? Instead of this particular use vectors and all, so matrix form, so we can write it in a very simple format, that is x cap or x dash will be equal to a into x of t plus b into u of t. Somebody want to tell anything? And y of t will be equal to what? C into x of t. So here the same thing we have written. So you can see that x of t equal to what? Here I will explain you. So here x of t is equal to, capital X of t will be equal to x1 of, is a column matrix, x1 of t, x2 of t up to xn of t. A will be equal to this one. A will be equal to this particular matrix, okay, n cross n matrix, and B will be equal to this one, okay, unit column matrix, okay. So and x, capital X cap will be equal to x1 of t cap, x2 cap of t and xn cap of t, like that. So and this is a, so x cap will be equal to a into x of t plus b into u of t, and y will be equal to what? C. C means what? Is the row matrix, c into x of t. Same thing we have written. Okay, so small representations changes, we have written like this. Okay. So after that, where a equal to what, b equal to what, c equal to what. So same thing we are representing. This particular representation is called what? Phase variable representation in canonical form. Phase variable representation in canonical form. Our representation is known as phase variable canonical form. Okay, so now after that understanding, if we are representing the same thing in the, so in general way, okay, so in general I can say that state model of single input, single output system is written as x cap of t will be equal to what? A into x of t plus b into u of t, and y of t will be equal to c into x of t plus d into u of t. So 90% of the time d into u of t will not come into picture, because input also we have taken. That is general equation. The general equation will not be holding good for many of the things. So that particular thing, after that we can go for the next thing. Okay, so here we'll represent, okay, so we'll take one small numerical. So like in exam, how the numerical will be asked, like that we'll take it. Represent the differential equation given below in a state model. Represent the differential equation given below in a state model. So what is this particular representation of a given differential equation which is in state model? I can say that. So that take the numerical, you can take the numerical, all of you. D cube y dt square dt cube. Okay, so plus 3 d square y by dt square plus 6 into dy by dt plus 7 into y of t will be equal to 2 into u of t. So this is the numerical they have given. So here while solving this particular numerical now, so we need to understand basic things. What is that particular basic things? So here, since the given equation is a third order differential equation, on what basis? Based on the highest degree of the differentiation, that is 3. So since the given equation is a third order differential equation, so we need 3 state variables to represent the system. We need 3 state variables to represent the system. So what are the particular 3 state variables? So let y of t will be equal to, so here x1 of t, see here x1 of t, x2 of t and x3 of t are the 3 state variables. So for this particular thing, we always go with the first thing, that is y of t will be equal to what? X1 of t. Y dash of t will be equal to the next variable. Y double dash of t will be equal to the next variable. So okay. Since here we have 3 variables here, order is 3. Okay, but still we don't consider that particular order. Why? Because we consider only the 3 state variables. The first state variable starts from the output, normal output y of t. So like this, it is going to start y of t. So x2 of t will be equal to what? Y dash of t. X3 of t will be equal to what? Y double dash of t. So this is the first understanding what we have to make it. So once it is been done, okay, since the given equation is a third order differential equation, 3 state variables has to be considered, and we can represent like x1 of t, x2 of t and x3 of t. 3 state variables we are considered. So since the differential equation is given, so the normal y of t or the output will be equal to first state variable, is x1 of t, and the differentiation of the y of t will be equal to the second state variable, and differentiation of y dash of t will be equal to third state variable, that is x1 of t will be equal to what? Y of t, x2 of t will be equal to what? Y dash of t, and x3 will be equal to y double dash. So here here you can see that I written here. Okay, so where x1 of t, x2 of t, x3 of t were state variables of the system. Okay. So now after we finding the state variables, okay, so we not exactly finding, just representing or considering the state variables. Okay, after that we need to consider differential state variables. So how to consider that particular differential state variables? I can say that we know that y of t is equal to what? X1 of t we have taken. We'll take a differentiation. Y dash of t will be equal to, take the differentiation on both sides. X1 dash of t. Clear? So x1 dash of t will be equal to x2 of t. Okay. X1 dash of t will be equal to what? X2 of t. See, x1 dash of t equal to what? Y dash of t. Y dash of t equal to what? X2 of t. That is what we are doing, x2 of t. Therefore, I can say that x1 dash of t will be equal to what? X2 of t. Similarly, I will take the next one. Y dash of t will be equal to what? X2 of t. So you differentiate both sides. Y double dash of t equal to what? X2 dash of t. Clear? So x2 dash of t will be equal to what? X3 of t. Why? Because here y double dash of t equal to what? X3 of t. Y double dash of t will be equal to what? X2 dash of t. So based on this one, x2 dash of t will be equal to what? X3 of t. That is what we can conclude. That is the equation number 2. Is that clear? So this is a very simple mathematics, very simple, primitive mathematics. Is that clear? So now after that we have to find out some other value, that is x3 dash of t, how it will come. So I can say that finally from the given differential equation we can write, okay, finally from the given differential equation we can write that. So y triple dash will be equal to, so here in this particular equation what they have given, so here y triple dash d cube of y divided by dt cube will be equal to y triple dash we can consider. So y triple dash will be equal to, you shift this 3, 6 and 7 terms and all to the right hand side. So we get like y triple dash of t will be equal to what? Minus 3 y double dash of t minus 6 y dash of t minus 7 y of t plus 2 into u of t. Clear? Now you replace all the values of y double dash in terms of differential state vectors x3. So x3 dash of t plus minus 7 x1 of t minus 6 x2 of t minus 3 x3 of t plus 2 into u of t. This is the equations what we get. Okay. So now in this particular thing, if I just want to calculate, okay. So what is the state x1 in the putting equations 1, 2 and 3 in the matrix form. So here is equation number 1, x1 dash of t, x2 dash of t, x3 dash of t. So in the equation number 1, 2 and 3 we have found out. You put all these equations in the matrix form. So if you put all these things in the matrix form, you will get like this. So just observe that one. If you have any doubt, please ask me. So once you written this one, so above equation is known as state equation, and this particular equation will be in the form of x dash of t will be equal to a into x of t plus b into u of t. This is in the form of this one. So where x of t will be equal to what? x1, x2, x3, where a is equal to what? This one, and b equal to, in this particular, the coefficient. We have taken the all this A matrix separately, B matrix separately, and X matrix separately, and X cap or X dash matrix separately. So now output equation matrix we need to find out. So in order to find out the output equation matrix, so y dash y of t will be equal to what? X1 of t. So this particular x1 of t we can be represented as y of t will be equal to what? 1 into x1 of t plus 0 into x2 of t plus 0 into x3 of t. So here 1, 0, 0. That means for 0 into anything is 0. So we have taken. So we need to consider all the state variables in the equation. That is why we have considered x1, x2 and x3. Clear? So x1, x2 and x3 we have considered like this. Y of t will be equal to 1, 0, 0. And this will be equal to in multiplied with x1. So this particular above equation can be represented in the matrix form in this particular way. That is y of t will be equal to 1, 0, 0, x1, x2, x3. We can consider. So this particular above equation is known as what? Output equation. So this particular output equation, which is in the form of y of t will be equal to what? C into x of t, where C equal to the row matrix, that is 1, 0, 0. Clear? So when you solve this particular, see, when you represent the equation, given differential equation in this particular format, so you have completed one particular numerical. Okay. So this is how a differential equation can be represented in terms of a state equation. So this particular equation is called as what? State equation, we say. Okay. So now after understanding this one, so some small derivation type we will see, that is a solution of state equation, that is case 1, that is homogeneous solution. So your homogeneous solution and heterogeneous solution it is there. So in homogeneous non-homogeneous is there. Homogeneous solution means a zero input response. So here a zero input response means input is not given, but the state is there. Okay. So and the previous outputs and inputs are there. That particular condition is called as what? Zero input response. Clear? So here homogeneous solution, that is a zero input response with input equal to 0, and the state equation x dash will be equal to what? A into x. So why it is A into x? Because plus b into u will be equal to what? 0, because u will be equal to what? 0. If the input is not given, u will be equal to what? 0. 0 into b is 0. That is why our matrix will be reduced to x dash will be equal to what? A into x. Reduced to A into x. So now taking the Laplace transform on both sides, we get s into x of s minus x of 0. So that will be equal to what? A into x of s. So taking the Laplace transform on both sides. So x differentiation. Okay, so x differentiation, if we take the Laplace transform, it will be s into x of s minus x of 0. That will be equal to what? A into x of s we get. So you take the x of s one term on one side, that is x into x of s minus a into x of s will be equal to what? X of 0. So when you take x of s common, so since it is a matrix, so we'll get that s into I minus a. Okay, so equal to what? X of 0. So x of s will be equal to what? Si minus a inverse, because we are shifting the LHS term to the RHS. In the matrix, it will become inverse into x of 0. So here x of 0 will get, so this si of si minus a inverse we consider as phi of s. We consider as phi of s. So this is the equation number 1. So where this particular phi of s is known as resonant matrix, where this particular phi of s is known as resonant matrix. Okay. So this is how we are going to find out the solution. Okay, x of s value we are going to find out. So here where phi of s is known as resonant matrix, so taking inverse Laplace on both sides of the equation, we get x of t will be equal to what? Phi of t into x of 0. Okay, so here x of s domain we convert it in time domain. It is x of s will become x of t, phi of s will become phi of t, x of 0 will be x of 0 only. Okay, so here phi of t means what is the particular value of phi of t? So inverse Laplace transform, it is 1 by inverse Laplace is 1 by L into 1 by L of s minus a inverse. So that particular value will be equal to what? E to the power of at. So according to the inverse Laplace transform value, so inverse Laplace transform of 1 by s minus a will be equal to what? E to the power of at. So e to the power of at is the value. So you replace the value of e to the power of at in this particular equation. X of t will be equal to what? E to the power of capital A into t of into x of 0. So here in this particular e to the power of at is there, no? So this particular e to the power of at is defined as state transition matrix. E to the power of at equal to what? State transition matrix. Clear? So now after understanding that particular state transition matrix, so we can go and see that what are the properties of a state transition matrix. So what are the properties? So phi of 0. So phi of t equal to so and so we got. Okay, phi of t is this one. So phi of t equal to what? E to the power of at. So this particular phi of t. Okay, so you replace the t with 0. So when you replace the t with 0, so phi of 0 will be equal to what? E to the power of a into 0. So this particular e to the power of a into 0 is identity matrix 1. E to the power of anything, e to the power of 0 is 1. Anything to the power of 0 is 1 only. So here in the matrix form, if you consider it, so it will be equal to what? Identity matrix. That's the first thing. second property when you say it. Okay, when you see the second property, so phi of t will be equal to what? E to the power of at. So now e to the power of at, taking the negative sign out of it, that means what it will become minus. So when e to the power of a minus of at to the minus, so yeah, it will become like phi of minus t inverse, or phi of phi inverse of t will be equal to what? Phi of minus t. Okay, so that is what I can say, that this particular equation, so phi of t will be equal to phi of minus t. That is the second property. When you're talking about third property, is a phi of t1. Okay, phi of t1 plus t2. So here instead of t, we have taken t1, t2. So in that particular case, it will become e to the power of a t1 into e to the power of a t2. So phi of t1 plus t2 will be equal to phi of t1 into phi of t2, or else phi of t2 into phi of t1. That means what? Multiplication on the other side is possible. So fourth property we can consider like phi of t to the whole to the power of n will be equal to what? Phi of nt. So if phi of t whole to the power of 2 means what? Phi of 2t. Similarly, phi of t whole to the power of n is phi of nt. That is the fourth property. Next is what? Fifth one. Which phi of t2 minus t1 will be equal to phi of t1 minus t0. Okay. So here in this particular case, here I can say that phi of t2 minus t1 minus phi of t1 minus t0. So in that particular case, it will reduce to phi of t2 minus t0. So if two terms, that is the t1 is getting separated, okay, phi of this one, so we'll get like this. So phi of t2 minus t1 into phi of t1 minus t0. Okay, so that will be equal to what? Phi of t2 minus t0. The middle intermediate term will get vanished. So these are all about the state transition matrix properties. So when we go for the next thing, that is a non-homogeneous solution. So when you're talking about the non-homogeneous solution, we need to consider the two responses also. So what are the two responses we have? One response is what? Zero input response. The second response is what? Zero state response. So that particular zero state response is there, no? That particular zero state response, zero input response, we have discussed about the homogeneous. So zero state response we need to consider. So here we can consider that a non-homogeneous solution, that is total response. Total response equal to what? Zero input response plus zero state response. So here consider the state equation given below. So with the initial condition x of 0. So we need to consider x cap will be equal to what? A into x plus b into u. So this is the one particular equation we have seen in the beginning only. The same equation we need to take it. So once we take the same equation, taking Laplace transform on both sides, so we get s into x of s minus x of 0. So that is equal to a into x of s plus b into u of s. So you take the x of s terms one side, so it will be equal to what? X of s will be the same similar to the last way. So si minus a into x of s will be equal to what? X of 0 plus b into u of s. So you shift the si minus a on the other side. So you will get x of s will be equal to what? Si minus a inverse x of 0 plus si minus a inverse b into u of s. So we know that phi of s, si minus a inverse is phi of s. We replace the value of this one to phi of s. So once we replace the value here, okay, so we take the inverse Laplace transform. So when we take the inverse Laplace transform, what will we get? We'll get like x of s will become what? X of t, and x of phi of s will become phi of t into x of 0 plus Laplace inverse of, see here two terms are there. So when two terms are there, I can say that Laplace inverse of phi of s into Laplace inverse of b into u of s. So here in this particular thing, it is phi of t into convolution with b into u of t. So here if phi of t value equal to what? E to the power of 80 into x of 0. Here also phi of t value is e to the power of 80 into b into u of t convolution. Okay, so since we need to remove this particular convolution, we can use that particular integration concept. Is x of t will be equal to e to the power of at into x of 0 uh, into integration of 0 to tau e to the power of a into t minus tau b into u of t into d tau. So that particular derivation you can able to see here. So here I can understand this one. So here x of t will be equal to this particular thing. So here I can say that its total response will be equal to what, 0 input response plus 0 state response. We are going to get it. Okay. So once we get the 0 input response and once we get the 0 state response, okay. So this is the non-homogeneous solution. This is non-homogeneous solution. So now after we understand this particular equation, we can see one numerical. So when we just see the particular numerical, that is determine phi of t. So when we determine the phi of t, if a value is been given, that is minus 2, 1, 0, minus 2, find the inverse of state transition matrix. So we have to understand that state transition matrix is phi of t. So phi of t will be equal to what? E to the power of at. E to the power of at means what? Laplace inverse of phi of s. Correct. So what is phi of s? S into I minus A inverse. So S into I means what? S is the value S variable. I means what? Identity matrix. A means what the value which they have given. So Si minus A value we can able to find out. It is S plus 2 minus 1 0 and S plus 2 is the value we are going to get it. So now Si minus A value once we find out, so we need to calculate Si minus A inverse. So what is the value of finding the inverse? In the matrix form, it will be like Si minus A inverse will be equal to what? Adjoint. Okay. Adjoint of Si minus A divided by determinant of the matrix Si minus A. So adjoint and matrix this one. So we can say that adjoint will be Si minus A and the determinant will be Si minus A. So we have to find out. So how to find the adjacent? So here adjoint of Si minus A will be equal to what? We need to find out this particular adjoint. How to find out? So here we need to do the reverse way, cross multiplication. We need to do it. So it will be resulting like this particular value, that is S plus 2, 1, 0, S plus 2. Determinant value, if you find out, you can get that S plus 2 whole square. So now if you find out phi of S will be equal to what? Adjoint of Si minus A divided by determinant of Si minus A. So we get 1 by S plus 2, 1 divided by S plus 2 whole square, 0 and 1 by S plus 2 we'll get. So taking the inverse Laplace transform, we can get like 1 divided by S plus 2 inverse Laplace transform e to the power of minus 2t. So here 0 and here is t into e to the power of minus 2t and here is also e to the power of minus 2t. This is the value we are going to get. So this is the phi of t value. Okay. So now this is the inverse. This is the finding out the state transition matrix. Okay. This particular concept is called what? Finding out the state transition matrix. So once we find out the state transition matrix, the inverse of state transition matrix, how to find out? So here phi of t inverse will be equal to what? Phi of minus t. Okay. So here wherever the t is there, you replace with minus t. So here minus will become plus, that is the inverse of state transition matrix. So this is the way of finding out the okay. So inverse of state transition matrix as well as state transition matrix normal. So here what we can understand is, so what we can conclude is very simple. the most some mathematical thing, matrix understanding is required here. Okay, nothing else is required. So matrix understanding, all those things are required here. So you need to understand all these things clearly. So next numerical is obtain the state transition matrix phi of t for the following system. So for the following system they are given. So here also obtain the inverse of transition matrix. So here also same thing they are given. So but the thing is what this particular format has been changed. In this particular format, a value is 0, 1, minus 2, minus 3. We need to take it. Find out in a similar way. Si minus a you find out. Find adjoint of Si minus a. So how to find out adjoint? Because we have to take the transpose. Transpose of the matrix, you take it. So you will get it. Okay. And then determinant of A we find out. And Si minus A inverse will be equal to what? Adjoint by determinant. So you will get this particular value. So S plus 3 and all this particular value you will get. So once you get this one, the phi of t will be equal to e to the power of 80 into L to the power of L inverse. So take the inverse Laplace transform, we will get like this. Similarly, lastly, we can find out the what you call for that inverse of state transition matrix in this particular form, that is phi of t. Phi inverse of t will be equal to what? Phi of minus t. So replace the t with minus, so we will get this particular answer. Okay, so here if you find difficulty in finding out the inverse Laplace transform, you need to do the partial fraction method. So once we do the partial fraction method, so we will get like this. So that is the first. So now after I think we'll stop this particular point. Okay, so the last class I can do it like converting a transfer function into state transfer state model. Okay, so how to do it and all we'll see in the next class. This is very simple concepts. So after that okay, so after that we have something like okay, so only thing is what after that we have to do some small process. So by the next class, around the 1 or 2 class, I will complete the module. So this particular content will be available on the MS Teams forever.